Today's topic is phase cycle. Phase cycle for SAP 1. The control unit generates the control words that fetch and execute each instruction. While each instruction is fetched and executed, the computer passes through different timing states. These different timing states are known as T states. These T states are periods during which register contents change. This is the architecture of SAP 1. Controller sequencer produces this 12-bit control word CP, EP, LM bar, CE bar, LI bar, EI bar, LA bar, EA, SU, EU, LB bar, LO bar. And this 12-bit control word controls the working of all other parts. So the control unit generates the control words that fetch and execute each instruction. While each instruction is fetched and executed, the computer passes through different timing states or T states. These T states are periods during which register contents change. Ring counter. In figure 1, symbol of ring counter is shown. It has an output of T equal to T6, T5, T4, T3, T2, T1. Ring counter produces this 6-bit word T. This is ring counter and it produces this 6-bit word T, which is T6, T5, T4, T3, T2, T1. At the beginning of computer run, the ring word is T equal to 000001. That is, T1 is 1 and T2, T3, T4, T5, T6, all other bits are 0. Successive clock pulses produce ring words of T equal to 000010, then T equal to 000100, then T equal to 001000, then T equal to 010000, then T equal to 100000. So successive clock pulses produces ring words in this manner that this one travels from right to left. Then ring counter resets to 000001 and the cycle repeats. Each ring word represent one T state. So these are six ring words and these represent 6 T states. In these 6 T states, out of these 6 bits only one bit is high, that is 1, and all others are 0. This is the clock signal, which is a square wave signal. The first cycle represent T1 state, then next cycle represent T2 state, then T3, T4, T5, T6 states, and then it resets to T1 state. These are 6 T states: T1, T2, T3, T4, T5, T6. In T1 state, T1 is 1 and T2, T3, T4, T5, T6 are 0. In T2 state, T2 is 1 and other T1, T3, T4, T5, T6 are 0, and so on. So this figure shows clock and timing signals. This is the clock signal, a square wave signal, and then these 6 T states: T1, T2, T3, T4, T5, T6. Figure 2 shows the timing pulses out of the ring counter. Initial state T1 starts with a negative clock edge and ends with next negative clock edge. This is the first state, T1 state. It starts with negative clock edge and it ends with next negative clock edge. In T1 state, T1 is 1 during the next state T2 is high, then T3 is high, and so on. The ring counter produces 6 T states. Each instruction is fetched and executed during these 6 T states. A positive clock edge occurs midway through each T state. This is the T1 state in which T1 is high and positive clock edge appears in the middle of this T1 state. And similarly for T2, T3, T4 and T5, T6, all other T states. Positive clock edge appears in the middle of each of these 6 T states. First 3 states are phase cycle while last 3 states are execution cycle. So there are 6 T states. First 3 T states T1, T2, T3 are phase cycle and next 3 states T4, T5, T6 that are execution cycle. First state T1 state is address state. The T1 state is called the address state because the address in the program counter is transferred to the memory address register MAR during this state. Figure 3a shows the computer parts that are active during this state. Active parts are light and inactive parts are dark. This figure shows active and inactive parts of SAP1 computer. Active parts are shown as light and inactive parts are shown as dark. So in this first T1 state, that is known as address state, in this state address from program counter is to be transferred to next part, that is MAR, memory address register. Controller sequencer CON, which produces 12-bit control word, and this control word is this CON, control word equal to CP, EP, LM bar, CE bar, LI bar, EI bar, LA bar, EA, SU, EU, LB bar, LO bar. And during this first state, that is T1 state, which is known as address state, address is to be transferred from PC, program counter, to MAR, memory address register. So in this state, these two bits EP and LM bar must be active. When EP is active, E means enable, P is for program counter. It enables program counter. If EP is active, it means when EP is 1, then the address from program counter will reach to this W bus, and from this W bus, this address will come to MAR, memory address register, only when LM bar is active. LM bar means load MAR, L for load, M for MAR, load MAR. Load MAR with the word that is on W bus. So LM bar is active when LM bar is 0. Out of these 12 bits, those bits which have bar are active when those are 0, and those without bar are active when these are equal to 1. So if a bit from this 12-bit control word is active, if it is without bar, it is active when it is 1, and when it is in the form of bar, then it is active when it is 0. Now in the first state, we have to send address from program counter to MAR. For this, we must choose EP and LM bar active. Then the address from program counter can reach to MAR. EP and LM bar are active means EP is 1 and LM bar is 0. So this control word in this control word we write EP as 1 and LM bar as 0, and all other bits are inactive. CP is inactive when CP is 0, CE bar is inactive when CE bar is 1, and so on. This is the first state, address state, T1 state. Next state is T2 state, that is known as increment state. Figure 3b shows the active parts of SAP1 during the T2 state. This state is called the increment state because the program counter is incremented. During this state, only CP bit is active and the controller sequencer is producing a control word of this. In this state, this control word, this 12-bit control word is shown here, and in this 12-bit control word in this T2 state, that is increment state, only the first bit, that is CP, is active, it is 1, and all other bits are inactive. CP is 1, C is for count, so it is for increment. The program counter is incremented and it is incremented only when CP is 1. All other bits are inactive, and this figure shows the active parts of SAP1. PC is active and controller sequencer CON is active, and active bit is CP in the control word. All other parts are inactive. So this is T2 state, that is incremented state. Next state is T3 state, that is known as memory state. The T3 state is called the memory state because the addressed instruction is transferred from the memory to the instruction register. Figure 3c shows the active parts of SAP1 during the T3 state. So in this T3 state, that is known as memory state, the addressed instruction is transferred from memory to the instruction register. Memory is RAM, and from RAM instruction is to be transferred in next part, that is IR, instruction register. So in this state MAR is also active, RAM, IR, instruction register, and CON, controller sequencer. These are the active parts of SAP1 during this T3 state, that is memory state. Memory state because from memory, that is RAM, random access memory, instruction is to be transferred from RAM to IR, instruction register. And in this case we must keep these two bits CE bar and LI bar active. When CE bar is active, CE means chip enable. CE bar is active. This enables the word in this memory in RAM to reach to W bus. So when CE bar is active, chip enable is active, the instruction from this memory from RAM is transferred to this W bus, and from this W bus this instruction goes to IR instruction register only when this LI bar is active. LI means load instruction register, L for load, I for instruction register. So when LI bar is active, it load instruction register with that word which is on W bus, which comes from the memory. So this is the third state, T3 state, that is memory state, and these are active parts of SAP1 during these states. Controller sequencer is always active in all these T1, T2, T3 states. In T3 state, active bits are CE bar and LI bar. So CE bar and LI bar are active. So we have CE bar is 0 and LI bar is 0. These are two active states, and other bits are inactive. And controller sequencer will produce this control word in which CE bar and LI bar are active. These are 0 and other bits are inactive. Fetch cycle, the address, increment and memory states. These three states, T1, T2 and T3 states, these are address state, increment state and memory state. These three states are called the fetch cycle of SAP1. During the address state, EP and LM bar are active and the program counter set up the MAR via the W bus. A positive clock edge occurs midway through the address state. This loads the MAR with the content of the program counter. During the next state, that is increment state, only CP is active, control bit. This set up the program counter to count positive clock edges. Halfway through the increment state, positive clock edge hits the program counter, which advances the count by 1. During the memory state, CE bar and LI bar bits are active and the addressed RAM word set up the instruction register via the W bus. Halfway through the memory state, positive clock edge loads the instruction register with the addressed RAM word. So these are the three states, T1, T2 and T3 states, and these three states form the fetch cycle. Next three states, T4, T5 and T6 states, will form the execution cycle.